You want to solve any function problem on the SAT. Well, I've got 3 keys to solving any function problem on the SAT. But first, I've got an SAT question, I've got a timer, I've got a sip of coffee. Let's solve it. If f of x equals x squared minus 6x plus 3 over x minus 1, what is f of negative 1? We're just going to plug in negative 1 everywhere there's an x. Negative 1 squared minus 6, negative 1 plus 3 over negative 1 minus 1. That equals 1 plus 6 plus 3 over negative 2 equals 10 over negative 2 equals negative 5. A is our answer. Key number 1. A function is just where an x goes in and y comes out. So a function is like a black box. X goes in, the function does stuff, y comes out. And if we look at here an example, we have x, let's make x 3. F of 3 equals 6 in this case. So x is 3, y is 6. So we go down here, anytime you see an x, you can plug in an x in the function and out comes a y. And for every x, there is only one corresponding y. We can use any letter. We can use f of x, r of x, q of x, etc. F of x equals y, which equals an equation. So if we look at this example below, we have f of x equals y, which equals 3x plus 2. So if we look at x here to the left, 0. F of 0 equals 3 to the 0 plus 2, which is y equals 2. So the xy is 0 and 2. Let's look at 1. F of 1 equals 3 times 1 plus 2. Y equals 5. X is 1, y is 5. Now let's look at x equals 2. F of 2 equals 3 times 2 plus 2, which means y equals 8. So the xy pair is 2, 8. So anytime we see an x and we see a function f of x, we know that we can plug in an x where you see an x in the function. Key number 2, work from the inside out. Nested functions, they work from the inside out. So if we look at this example here, we have t of x equals x plus 2 and p of x equals x plus 8. And what we're wanting to solve for is t to the p of x plus 3 and x equals 2. So do p of x first. So p of 2 equals 2 plus 8 equals 10. Then we have t to the p of 2 plus 3. Well, p of 2 equals 10, so t to the 10 plus 3. So we have function t of 10 equals 10 plus 2 equals 12. So we have t of 10 plus 3 equals 12 plus 3 equals 15. Last key, know that functions move. F x minus 1, move the graph right by 1. F of x plus 1, move the graph left by 1. F of x plus 1, move the graph up by 1. F of x minus 1, move the graph down by 1. If we look at this example of f of x equals the absolute value of x, the first graph to the far left is just what the graph normally looks like. Then we're going to translate it by doing plus 1, absolute value of x plus 1. That's what the graph would look like. Minus 1, the graph moves down 1. X, the absolute value of x plus 1, where everything is inside of the absolute value bars, we move it to the left. And then when we have the absolute value of x minus 1, we move that graph to the right 1. Let's look at steepness of the graph. Anything above 1 makes the graph more steep. So 2x means the graph is going to move up faster. Anything between 0 and 1, but not 1, makes the graph less steep. It moves up slower. So if we look here, 1x, we show the normal graph. If we look at to the next one, 2x, we see the graph is more steep. And then if we look at to the last one, negative 1x shows the graph less steep. It moves up slower. Then we have reflection. So if we look at x squared and we make it reflect about the x-axis, it's going to look like this, where it's flipped over the x-axis. If we look at x cubed, this is what the graph would normally look like. But when we reflect it about the y-axis, we see that it's flipped almost from right to left. Let's look at problem number 2. The complete graph of the function f and a table of values for the function g are shown above. The maximum value of f is k. What is the value of g of k? So we are solving for the value of g of k. And the graph shown above is f of x. So we're asking for the maximum value of f is k. So let's look at the highest point on the graph here. And we see that the highest point, the maximum value of f is k, so the highest point is 3. Then we need to know that k equals 3. So then we need to plug in this k for g of 3 equals what? Let's look at the chart above. We have 3, and our answer is 6. B is our answer. Problem number 3. We see a graph above plus a little chart to the left of that. So then we have the penicillin concentration in micrograms per millimeter in the patient's bloodstream t minutes after the penicillin injection is modeled by the function p, defined by p of t equals 200b to the t over 5. If p approximates the values in the table to within 10 micrograms per millimeter, what is the value of b rounded to the nearest tenth? Okay, so we're asking for what is b? What is the value of b? That's what we're asking for. B equals what? So let's set up our equation. P of t equals 200b to t over 5. Well, we have a chart above here which has all of our t's and p's. So if we start off with 5 and 152, we can plug in 5 where t is, so t equals 5, and p equals 152. So we have 152 equals 200b 5 over 5, which means 200b to 1. And then we have, to isolate the b, we take 152 divided by 200, and that's our b, 152 over 200, which roughly equals, because we're rounding to the nearest tenth, 0.8. And that is our answer. Take a look at some of the homework below, get some reps in, and then watch the next video.